Hi, I'm Jen Simmons, and I'm here to share the latest news about WebKit, the web browser engine that powers Safari. The WebKit and Safari teams have been busy this year. I'm excited to share what we've been working on and how it impacts you as you make websites, web apps, and web content. We've already shipped a lot of new web technology, including CSS Grid Lanes, Navigation API, largest contentful paint, and many more. The first beta of Safari 27 brings over 60 more new features, including Customizable Select, image sizes equals auto, the stretch keyword for layout, and more. Later in this session, I'll walk you through 5 of the most exciting new features. Stick around to see what CSS Grid Lanes can do, learn how you can customize Select UI, explore what the model element brings to the web, and more. But first, I think what you might find most exciting as a web developer is the time my team put in this year to improve the quality of WebKit. I hear from web developers that it's challenging when you have to work around a problem in our browser engine. You expect more. We hear you, and we set out to greatly improve the quality of existing web platform features. We put our focus there this year rather than on implementing a whole lot of brand new ones. When I look at what we've accomplished so far, a few clear themes emerge. I want to share one quick story from each. First, compatibility. A big part of this work focuses heavily on the things that directly affect users, making sure real websites work for real people. Your users are our customers, and we want them to have a fantastic experience. My team got a report about a particular website. When users typed emoji, the totally wrong character appeared. But why? Well, normally, when a user presses a key, the browser sends a Unicode number to the website. The number for this A uses 7 bits of data. Some websites want to intercept keyboard input and process it with JavaScript. For decades, websites used the from charcode method to turn those numbers back into characters. From charcode can handle data that's 16 bits or smaller. And for a long time, even as Unicode grew, that was enough. But then a lot of emoji came along, and these new characters got assigned bigger numbers. This one needs 17 bits. And on websites that still use from charcode, that number got truncated to 16 bits, which maps to a totally different character. So what should we do? Try to get every website to stop using from charcode? That's not realistic. Users want to type emoji now. So my colleagues adopted a clever workaround. Now, when a user types a character with a code point beyond 16 bits, WebKit doesn't send the number to the website at all. The emoji arrives as text instead. No number, no truncation. And now, everyone can type a face holding back tears on any website they wish. It's one example of the many changes we've made to directly help users. But as a web developer, you just want your work to become easier. My team is also working to rebuild the foundations of WebKit in quite a few areas. Sometimes we just got to start from scratch to pay off technical debt. This deep work isn't necessarily visible on the surface, but it makes everything built on these foundations more reliable. Here's one: block and inline layout. Block elements end up nested inside of inline elements all the time. The code for handling such a layout was over 2 decades old and had grown tangled and hard to maintain. So we rewrote it from scratch with a new architectural approach. You probably won't notice, but the work did fix a bunch of issues. My team is also going deep to make significant progress in specific areas: media and video playback, scrolling, SVG, accessibility, WebRTC, even HTML tables. Each of these areas needed something different. Take SVG, for example. To make real progress, we needed the web standard to have more clarity and detail. Only there was no active SVG working group, so That's how my teammates accelerated their journey, by reviving and leading a new standards effort. For example, what happens if a web developer makes an SVG with a radial gradient but doesn't explicitly define its focal point with the fx and fy attributes? In SVG 1, the spec text describing the initial values of fx and fy was confusing, and different browsers interpreted it differently. Now, SVG 2 removes all ambiguity. The initial value is clearly defined. And we're updating WebKit in Safari 27. We've made over 75 improvements to SVG so far, and there's definitely more work to do. A lot of the improvements my team is making are to better align with web standards, both to shore up the interoperability of long-standing web technology and to keep up with the evolution of new features. Here's something new, the CSS random function. You can use it to generate random values. With this code, width and height get random lengths. You can name random values to reuse them, but originally, names were scoped per instance. Each time the box class was called, new random values got calculated. We shipped random in Safari 26.2, but then developers argued that maybe this could be better. After discussion at the CSS working group, these names were redefined to be global by default. Now all these boxes get the same random size. We updated the scoping of names in Safari 26.5. We're still the only browser with support, so there was time to make it better. We're keeping up with recent changes to features like anchor positioning and view transitions, and we're strengthening older features too. There are hundreds of updates to better align with web standards. We want it to be easier for you to create websites that just work in every browser. And the fifth area of improvements, integration. A bunch of improvements make sure separate features integrate together correctly. In 2014, WebKit shipped support for the sizes attribute in HTML, enabling responsive images. In 2018, we shipped support for the CSS min and max functions. But when we did, we somehow missed implementing support for min and max inside of sizes. Thank you to the developers who filed issues about this. When Clamp came along in 2020, we didn't do it then either. This year, we circled back and closed the gap in Safari 26.4. These are the kinds of problems that we want to keep finding and fixing. We care deeply about the experience people have when interacting with the web on our platforms. Browser engines are huge, and we rely on the feedback and contributions from developers to help identify pain points and inform our priorities. Millions of apps in the App Store take advantage of web technologies built into WebKit and JavaScript core, including apps for iOS, iPadOS, macOS, visionOS, and even watchOS. We care about the web, and we sincerely hope our efforts make a real difference in your success. With this focus, we were able to tackle over 1,100 feature improvements and fixes since last fall. That's a record for us. We'd love to have you test your projects in the most recent versions of Safari Technology Preview or Safari Beta. And if you are having problems, please file an issue. We know there's more to do. I only covered a few examples of our quality efforts. For all the detail, check out Safari release notes. Quality improvements are a huge part of what my team has been doing this year, but it's not all. We've shipped some genuinely exciting new features too. In the rest of this session, I'll go through several. Starting with CSS Grid Lanes, which shipped in Safari 26.4. Use it to create the classic masonry layout in pure CSS. No JavaScript needed. It can handle use cases you've maybe never considered before. The code is simple, and it includes all the power of CSS Grid to define tracks. And yes, it works in the other direction. Check out our field guide to grid lanes at gridlanes.webkit.org. Click through different configurations to experience how it works and explore the many demos. Use Safari Web Inspector to better understand and adjust your layout. Enable order numbers to reveal the order of items. It's super helpful for adjusting flow tolerance to finesse the experience for users tabbing through content. And watch Learn CSS Grid Lanes, where Brandon will walk you through exactly how to create these layouts. Customizable Select is another exciting feature coming to the web. Safari 27 transforms the select element. It's easier than ever to implement a fully custom design to match your website or web app with great accessibility automatically. You start by applying appearance-based select in CSS to the select element. Immediately, the control starts inheriting more CSS, including your font family, text color, and background color. Also, apply appearance-based select to the new picker pseudo element. This unlocks the ability to style the menu of options that pops up when a user taps on the control. Other brand new pseudo elements let you target specific parts of the control, like the checkmark and the picker icon. Now you can add additional HTML inside select, like subtext describing the details or images representing each option, all while leveraging the benefits of using a real HTML form control with its accessibility and robustness. Use Grid or Flexbox to lay out the options, or anything from CSS, and make it look nothing like a traditional drop-down menu. Tim will teach you how in his session Rediscover the HTML Select element. Last year, we shipped Model, a brand new HTML element for Safari in visionOS. In Safari 27, Model is coming to iOS, iPadOS, and macOS. It joins image, audio, and video in the family of elements that handle media files, this time putting 3D models into HTML. By adding a model to your website, you can provide a way for users to check out products, preview an object in their space, or just have a cool experience. The markup works like you would expect. You can keep it simple, or just like the other media elements, you can use source to link to multiple files in different formats. You can optionally include attributes like environment map to provide custom lighting for your model, or stage mode, which sets the default interaction behavior. Target your model with JavaScript to open up a wide range of possibilities. Or wrap the model in rel equals AR to let users on iOS and iPadOS see the product in their space. You can find much more about making and using 3D models on developer.apple.com. There's years of documentation, videos, and sample projects diving into what's possible. Watch Get Started with HTML Model Element to learn more. Alexei will explain where to get a 3D model, how to optimize it for the web, and what to do in JavaScript. In visionOS 27, Model goes even further with immersive website environments. A user can go to your website in Safari, tap to open an immersive environment, and step into the model you provide. Maybe you've made an immersive video game and you want to give potential customers a way to preview it. Maybe your site sells theater tickets. You can show people the view from their seats on any platform, and then, in visionOS, they can experience the whole theater. There's a new immersive API for manipulating models. It works just like the full screen API. Learn all about it watching Explore Immersive Website Environments in visionOS, where Jean will show you how he built the theater. And then there's web extensions. Not that long ago, making a browser extension meant creating entirely separate projects for each browser with different code using different APIs. That's why so many extensions only worked in one browser. Things started to change in 2017 when Mozilla deprecated support for Firefox add-ons and committed to a cross-compatible feature. In 2020, Safari 14 shipped support for Safari web extensions. And then, in 2021, we led an effort to create the W3C Web Extensions Community Group and turn these ideas into official web standards. Today, the dream of an interoperable extension future is becoming a reality. You can create an extension using one code base, one set of scripts, one manifest. It's all interoperable HTML, CSS, and JavaScript, just like the rest of the web. You just have to know how to package and distribute your extension to the users of each browser. But if you don't use Xcode or even have a Mac, how can you distribute your extension to Safari users? Now you can use the Safari Web Extension Packager. It enables you to package and distribute your extension using App Store Connect from any web browser on any operating system. Today, it's easier than ever to reach Safari users. You can read the documentation to learn how on developer.apple.com. And watch Create Web Extensions for Safari, where Kiara will guide you through how to build a web extension from the ground up, as well as how to use App Store Connect. Finally, I want to quickly mention MapKit JS. It's a tool you can use to embed interactive maps on your website or web app, all while preserving the privacy of your users. It works in all browsers on any operating system. Learn all about it at developer.apple.com. My team has done a lot of work this year. WebKit is packed with improvements. I truly hope these efforts make your work more satisfying, more successful, easier, and maybe more fun. Check out our website at webkit.org, where we teach all about the new features in every release of Safari. There, you can learn more about what's in Safari 27, watch other WWDC sessions about web technology to dive deeper, and file issues at bugs.webkit.org. We'd love to hear from you and to know what more we can do to support your work making projects on the web for people to use and enjoy. Thanks for watching.